So we are going to derive now equations of motion. Means an equations which will describe the motion entirely. Let's take help of this first one. So we know acceleration is equal to dv by dt. So this I'll rearrange a dt equal to dv or dv equal to a dt. At t equal to 0, as a is a constant, so I'll take outside. So at t equals 0, what is the initial velocity of body u? At any instant of time, let v be the velocity. This is t. So integral of dv will become v, upper limit v and lower limit u. A, this will be t 0 to t. So upper limit minus lower limit. Here I think we are going to put like upper limit minus lower limit. A into this will be t minus 0. So v minus uat. Okay, I think rather than every time integrating, there's a one generalized formula. The first formula for what is this formula? It will give us relationship between initial velocity, acceleration. Here A means here uniform accelerated motion, instantaneous acceleration here. What is t? T is the velocity, the time at which velocity of the particle is v. V is the velocity of the particle at time t. U is initial velocity. So we define these things. So what is u? Initial velocity. What is v? Or velocity of a body at time t. So what is the meaning of this? I'll bring that scooter. Oh, where is the scooter? It's here. Yeah. See, why I'm bringing this scooter so that students will understand what they are learning. So most of students, they think that particle books, in the books, it will be given particles. So students will think that, okay, something we should imagine. Okay, now we are in 21st century. We do have several objects around us. Now this is the person is moving on the road. At t equals 0, what was the velocity of him? At t equal to 0. After some time t, what is the velocity of this scooter? Let it be t. Let it be v. What is the time? This is the interval of time. Able to understand? So in that interval of time, some distance also covered. So what is the distance covered? Will be s. So we will try to get a relationship for this also. Okay, agreed. This one. So at time t equals 0, the particular object is here. After some time t, it will cover some distance. And in what direction the acceleration is said to be in this direction. Definitely the velocity v is greater than u. You can see it's describing accelerated motion. Okay, I'm interested now the distance. So the same equation, I'm going to take help of this one. V equal to u plus at. What is v? ds by dt. This ds u dt plus at dt. Then this will be 0 to s, 0 to t, 0 to t. So at t equals 0, what was the position of particle? It was here at origin. So s will become equal to 0. Are you seeing this? The distance covered is s, no? So this will be s at time t, it will cover a display, it will have a displacement of s, that one. So this will become s 0 to s u t so this will be s minus 0 u t minus 0 a by 2 t square minus 0 square. Okay, this is the equation which will give us the relationship between displacement displacement of a body in time t. Fine. Okay, the last one more equation we will search. So how this v, u, how this final velocity v, initial velocity u, acceleration s, they are related. So let's try to get one more relationship. So this acceleration, what we have, I can also write it as a equal to dv by dt. This I'll rearrange. So what is ds by dt? ds by dt is what? The speed, no? So this will rearrange. Okay, this is the limit. As acceleration is constant, I'll take outside the limit 0 to s uv. So when the body is at origin, when s equal to 0, this point will be s equal to 0. This point will be s equal to s. So when body is at origin, what is the speed of the body? Initial velocity u. When the body is at a distance s, what is the speed of the body? Let it be v. So this will become a okay, this will become 2as v square minus u square. So the final equation is v square minus u square equal to 2as. There's a third equation which will give us relationship between the initial velocity, final velocity, acceleration, and displacement. What about this? This will give us relation between the initial velocity, time, acceleration, and displacement. Equation 1, that will give the relation between the final velocity, initial velocity, acceleration, and time. Every time, instead of integrating like this, we are going to take help of this one. So all these equations are valid only when they're valid only when acceleration is constant. So these are called as equations of motion. 1, 2, 3 are called as equations. 1, 2, or 3 are called as like equations of motion. So they are valid. So the equations of motion are valid only when acceleration remains constant. Okay, there's a strict condition because these equations are derived only when that acceleration remains constant. You can see that we brought that a outside integration. No? If acceleration constant only, then only we end up the equation of this kind. This is for accelerated motion. What happens if there's a retardation? I think the same equations. You